we are from Group 1 and we will be presenting about least square solutions and best fit curves for our dataset monthly youth unemployment. So here is our group members. The first one, we have Abdul Qayyum Kamil bin Ihsan, Ismail Fahmi bin Ja'far, me, Amira Natasha binti Azli, and Nur Aliya Natasha binti Zakaria. Next, I will be presenting about the introduction dataset description. The monthly youth unemployment rate dataset was retrieved from Department of Statistics Malaysia, DOSEP. The dataset is publicly accessible for analysis and research and does not require a subscription or license, assuring flexibility and credibility. Since the information comes from a reputable government source, the dataset follows standardized collection and reporting procedures, which increases its legitimacy and applicability for the study. The report published is based on LFS, which stands for Labour Force Survey, and the application of LFS is based on the instructions and guidance of the International Labour Organization, ILO, with reference to the surveys of economically active population, employment, unemployment, and underemployment, and ILO manual on concepts and method. The survey, which is conducted monthly, offers data on the labour force, employment and unemployment rates in both urban and rural regions, as well as at the federal and state levels. A meticulous and systematic approach of data collection and analysis has been upheld across time to provide comparable time series statistics. So this is our data of monthly youth unemployment rate in 2016. We extracted 10 points from the whole dataset to proceed with the next steps of our project.
Next, we are going to the implementation part. First, we change the data into the matrix form, but before that, our FT in the dataset shown as date, but we change it into month. And next, we define month variable from the dataset as FT and unemployment rate variable as T. We form it into one column for each variable for matrix T and matrix FT. Then, we plot the scatter plot graph, and the graph shows no patterns.
Then, we substitute all the data points into the equation of FT equal to A plus BT plus CT squared. Next, we will form it into the matrix of AB. For the first column of matrix AB, we put the scalar of A, which is all 1. Then for the second column, we put the value of T, and for the third column is the value of T squared, seeing it is the scalar of B and C. Then for the vector B column, we use the FT values and we put the matrix in non-homogeneous form.
Then, reduce the matrix using reduced row echelon form to show that the data is inconsistent. We plus row 2 until row 10 with -1. And we get our fourth row, that is 0 equal to 3. Hence, there is no solution and we can conclude that the system is inconsistent. Since the data is inconsistent, we can calculate the least square solution using normal system. First, we find A transpose A, and the second, we find A transpose B, and we get the answer shown in the slide.
So, from the result of the multiplication between A transpose and A, we will find the determinant of A transpose A. We do this to determine whether the system has unique solution or many solutions. So from the answer that we have calculated earlier, the answer is 17.2618, which we can conclude that it is not equal to 0. Hence, the system has unique solution. So, for the next one, from the result of multiplication between A transpose A and also A transpose B, we will use them to obtain the row echelon form by using the Gaussian elimination process. So from the REF that we have obtained, we will get the simultaneous equations which we will solve to get the least square solutions, which are the A, B, and C. Hence, from the answer that we have gotten, the quadratic equations will be formed. From the quadratic equations that we have obtained from the previous steps, we will use it in order to sketch the graph of best fit quadratic curve.
The error vector and its magnitude are determined by the formula error vector equals to b minus ax, and the magnitude is used to determine if the error is small or large. For error vector, we substitute all the information into the formula and we will get the answer. Now, to find the magnitude, using the answer in error vector, we square each answer and plus all together, and lastly, we square root the sum of squared error vector and we get the magnitude 8.6859.
Next is the conclusion. The monthly youth unemployment dataset, which provide information about our country's unemployment rate, that is appropriate and very useful because it allows us to find the best fit quadratic curve using Maple software and manual calculation. Based on both calculations, the best quadratic curve equation is ft equal to negative 96.2661 plus 29.9260 and minus 2.1906 squared, and the calculated magnitude of error vector is 8.6859, suggests a minimal error in determining best quadratic curve equation. It is demonstrated that our dataset provides a good fit model. That's all from us. Thank you.